This tutorial explains the contact analysis capability of FIS software. Both the beams are of length 200 mm and have a cross-section of dimension 20 by 20 mm. The gap between the beams is 2 mm and the overlay is 50 mm as shown in the figure. Both the beams are made of aluminium, which is having an Young's modulus value of 68.67 GPa and Poisson's ratio 0.3. The beams are fixed at the ends and a pressure load of 5000 Newton per mm square is applied on the top of the beam, as shown in the figure. Due to the pressure load, the top beam moves down and applies load on the second beam, resulting in the displacement of the second beam. Now let us see how we can solve the problem using FIS. For creating the geometry, first we need to create the key points. For that, go to Geometry, Key Point, Create by XYZ. Create key point at 0, 0, 0 and 220, 0. Now create a rectangle considering these 2 points as the corner points. Go to Geometry, Surface, Create, Rect 2P. Select the points from selection box and pick the 2 points to create the rectangle. The surface will be created. Now, we have to create the 2D mesh on the surface and extrude it to create the block mesh. For meshing the surface, go to Mesh, FE Mesh, Quad. In the surface parameter box, enter the surface ID or click on the surface to highlight it. Enter the initial size for element edge so that it can divide the edge into a number which is equal to total length divided by initial size. Once the edge is divided into a number of divisions, click on the division edge after clicking the divisions parameter box to increase or decrease the number of divisions as required. After adjusting the number of divisions, click OK. The mesh will be generated. For extruding the mesh, select Mesh, Element, Create, Extrude. Pick all the elements created in the Element dialog box. In the Along dialog box, enter the value as 0, 0, minus 20 and in the Segments dialog box, enter the value as 5 so that the 20 mm extrusion will be divided into 5 equal parts. You can rotate and see the extruded mesh. For rotating the model, either click on the Rotate button on the menu bar or use Ctrl plus left mouse button. Now, the second part is to be created. A copy of the already created mesh can be used for that. Go to Mesh, Element, Copy and Translate. Pick all the elements. Give the magnitude as minus 22 since 2 mm is the gap between the two parts and 20 mm is the depth of the part. Select direction as Y. We have created the second part, but it is not at the required position. For moving the part to the desired position, go to Mesh, Element, Move, Translate. Select the elements newly created and enter the magnitude as 150. Select the direction as X. Click Apply. The second part will be now in the required position. Since the modeling part is over, we can now go for loading and boundary condition. Go to Load Boundary Condition, Structural, Displacement Boundary Condition, Add. Pick the nodes on the left end of the first part and right end of the second part. In the BC value parameter box, pick on the box corresponding to that parameter box and tick all the translational degrees of freedom. Click Apply. The boundary condition will be applied. Next, the pressure load has to be applied. For that, go to Load Bar Boundary Condition, Structural, Pressure, Add. Select the element face where the pressure is to be applied as shown in the video. You can use rectangular selection using the mouse. Enter the value of pressure as 5. The area for the application of pressure is chosen such that area into pressure will give total load. Now the contact property has to be defined. For assigning the contact region, go to Load Bar Boundary Condition, Structural, Contact, Add. The contact is defined by specifying hitting nodes and target surface. In this case, the nodes at the right and bottom of the first part are the hitting nodes, and element faces on the left and top of the second part are the target surfaces. Select the hitting nodes and target surfaces as shown in the video and click Apply. The contact property is now applied. The two parts are having material property of aluminium. For applying the material property, go to Property, Material, Structural, Isotropic, Add. Select all the elements. Click on the box corresponding to Material Data. Enter Young's modulus as 68.67 GPa, which will be 68670 Newton per mm square, and Poisson's ratio 0.3. Click OK. The material property will be assigned to the elements. Now, all the loads and properties are assigned, and we have to define the analysis type and solver option. For that, go to Analysis, Analysis Type. Click on Analysis Type button and select Nonlinear Static. After that, go to Analysis, Nonlinear Static, General, Add. Enter minimum load factor as 0.1 and maximum load factor as 1, so that the total load will be applied in 10 steps, where in each step a load equal to total load divided by 10 will be added to previous load step. Enter maximum iterations as 20, tolerance as 0.0001 and method as Newton-Raphson. If you want the stress output as well, tick on stress output. All the inputs required for the analysis has been defined. Before solving the problem, the project file needs to be saved. For saving the file, go to File, Save. Save the file to a directory of your choice with an appropriate file name. After saving the model, we need to solve the problem. For solving the problem, in Feast, go to Analysis, Run Solver, or click on the Run Solver button provided on the menu bar. Click OK on the Confirm dialog box which appears. You can see the status of the solution being done at the right bottom corner. After completing the solution, the Finished Successfully dialog will be displayed in the message box. Turn off loads and boundary conditions using Show Load Bar BC button in the menu bar. Different types of output manipulations are possible by Previn. First, we can see the deformation. For that, go to Post Deformed Shape. Select the required load step from the parameter box. After picking a particular load step, you can go to the next steps using up and down arrow key. Turn off post-processing. Now you can see the contour plot of displacement, stress and strain. For that, go to Post Contour. Select item as displacement and component as T resultant. Select the load step and click Apply. You can see the displacement contour plot. In order to animate the load step, tick Animate Step. You can see the deformation through different load step. Now, select item as stress and click apply. You can see the von Mises stress through different load steps as animation. Turn off post processor. Go to post view results. Select item as displacement and pick the required node from the window and click apply. You can see the displacement values of that node in a tabular form. Change item to stress and click apply. You can see different stress values.